Welcome, students. Thank you for coming back to watch the video like I asked. I hope you guys are enjoying your day off, and we'll take this 10-15 minutes to watch through this video 2 times. Once just to watch it straight through, and again, pausing when you need to, jotting down your notes, doing that sort of thing, okay? Trying to keep this short. Let's see how this works. Here we go. After watching this video, I'd like you to be able to do 2 things. Number 1, graph a quadratic inequality, which works the same way as it does with linear equations, and then also solve a linear inequality algebraically. And there's a little bit more of a trick to that. That's where people get a little confused, but hopefully after watching the video, you're ready to tackle this tomorrow in class. First, like I said with the graphing, everything is the same as it was with linear equations. So we shade above when it's greater than or when it's greater than or equal to, and we shade below when it's less than or when it's less than or equal to. Similarly, we will do a dotted line for greater than and for less than, and a solid line for greater than or less than or equal to, greater than or equal to, less than or equal to, okay? All that's the same. So if we have a shade above for greater than, it'll look like this. Note you shade above the parabola and the line is dotted. If it's greater than or equal to, you shade above, but the line is solid. Dotted line less than, dotted line shade below. Less than or equal to is a dotted line shade below. Okay, this is a good time to pause if you need to jot these down. I would give yourself an example of each one, but just a sketch. Okay, part 2 now. This is the solving part. Now, if you read the equation, we have x squared plus 3x minus 40 is greater than or equal to 0. And what we want to figure out is where this parabola, x squared plus 3x minus 40, is greater than 0. Well, if we look here and move up, there it's greater than 0. And here, it's greater than 0. The part in the middle, that's all less than or equal to 0. That's not the part we're looking for. We're just trying to find these 2 ranges. Now, how do we find these 2 ranges? Well, we're going to use some compound inequalities, which I'll show you here at the end. But we start off first by graphing it. And if we can graph it and we can find the zeros, we're in business. Now, if we can't graph it and find the zeros, then of course there's solve by factoring, and there's also solve with the quadratic formula, which always works. But graphing is the simplest because it also helps us visualize. And even if you can't actually solve it with graphing, it still helps the end process if we have a graph. So I always try and graph these first, calculator or otherwise. Once we have it graphed, we see pretty quickly my zeros occur at x equals -8 right here, and also x equals 5. Those are my 2 zeros. But I want to figure out where the equation is greater than or equal to 0. So I'm looking for the parts where it's above. So that's the values that would make the original inequality true, right? So if I picked x is -9, well, that would also make the inequality true, as would 10, and so on. Same thing over here. 5 would work. 5 would make it greater than or equal to 0, but so would 6, and so would 7, and so on. So anything in these ranges ends up actually being part of my solution set. And because I've got these ranges where where the parabola is above the x-axis, my final answer ends up being x. Oops, let's see if we can get that out of the way. Nope. X is less than or equal to -8. So anything less than or equal to -8, anything to the left of -8, that will be part of my solution set. Or x is greater than or equal to 5, and that's anything over here and on up and forever. Okay, so we end up with this or inequality. Either of those values or either of those sets of values will make the original equation true. So just for example, if I plug in -10, -10 squared is 100, 100 plus 10 times 3 is 30, so 100 plus 30 is 130, minus 40 is 90. 90 is greater than or equal to 0, it makes it true. I could pick a value on the other side as well and verify that it is true. Meanwhile, I could take a point down here like 0, -40, right? So I plug 0 in for x, and I get 0 squared, which is 0. 3 times 0 is 0, minus 40. -40 is not greater than or equal to 0, so therefore I do not include this middle portion as a part of my solution, because that's going to be below the x-axis and is not going to make this true. But these 2 ranges over here, x is less than or equal to 8, x is greater than or equal to 5, anything in those 2 ranges will make this true, and that's what you're trying to find. Find the zeros, find the range that makes it true. Now, Of course, we have to consider what happens when it's less than. And to make this video simpler, I just used the same parabola. So the zeros are going to be in the same spot, okay? But we've changed the sign. So now we're looking for where it's less than or equal to 0, which, as you can see, is going to be this range down here. So the zeros are still at -8 and +5. I haven't changed the equation, but now I'm looking at a different spot in the graph to make it true. So that's this where it says right here to determine the range that makes the original inequality true. We already showed everything over here, that's above the x-axis. That's greater than 0. Same thing, above the x-axis, greater than 0. But between -8 and 5, stressing that between word, that's going to actually make everything true, which includes that 0, -40 that we checked earlier. So in this case, the parabola the parabola is below, typo, parabola is below the x-axis when x is less than or equal to -8 and x is less than or equal, oh no, I read that wrong, oh my gosh. X is greater than or equal to -8 and x is less than or equal to -5. And I chose the and because we got to make sure that we make both things true in this case, right? So when you're looking at the area between the two zeros, between the two zeros, that's an and situation. But if you're looking at the area on the outside of the two zeros, that's an or situation. So here's my recommendation as we're getting ready to wrap this up. Graph the parabola, identify the zeros, and then verify if you're going to do an and situation where you're shading the area in between, or not even shading the area in between, you're just looking at the part of the parabola that's between those two zeros, or if it's outside of the between part, if that makes any sense, you're going to be looking at these ranges and you'll use an or inequality, okay? Take a minute, pause the video, rewind it, rewatch it, okay? Go through this. If you understand the basics of this, we'll be ready to rock and roll come class time tomorrow, and we should be in good shape. Thanks for watching, guys.